Hello everyone. In this video we want to make a review for lesson 1 and lesson 2 from unit 2. First I want to start with you solving questions on page 37. You have true or false questions. Let's solve them together. Let's start first. Sound reach our ears as waves, so this one, think about it, so this one is true. Loud sounds are not harmful to human, for sure, this one is wrong. All animals hear the same range of frequencies, think about it, try to remember, so this one is false. Sound can travel in outer space vacuum, no particles, empty space, so this one is false. Sound can travel in water, the water it has particles, so this one is correct. Let's continue by talking about this lesson by studying page 38. On this page I want you to understand and memorize the meaning of vibration. This part is very important. Complete back and forth motion of an object. Here also I want you to memorize all of this paragraph. All of this paragraph is very important. It's talking about how the sound is longitudinal wave. Longitudinal wave, as you know, the particles of medium vibrate in the same direction that the wave travels. Also, it has another name. It has a compression wave because they are made of compression and rarefaction. Okay. A compression is the part of longitudinal wave where particles are close together. Rarefaction is part of the particles are spread apart. Okay. This one here very important. Go now to question 6. Question 6. This figure is very important. It shows the rarefaction, how the particles apart from each other, and compression, how the parts are close to each other. So here also the answer for this question. I want to show you the answer. A is compression, as you see, close to each other. The B is rarefaction because they are apart from each other. And now let's go to page 39. On page 39, it's talking about how do sound wave travel. As you know, because they are mechanical waves, they need they need particles. If it's empty space, they will not be able to travel. So sound wave travel in all direction away from the source, as here. So okay, from the source. This part very important. All matter, solid, liquid, and gas is composed of what? Of particles. A sound wave travel by what? By disturbing the particles in matter or a medium. This part very important. Also, I want you to know this one here. In vacuum, there are no particles to vibrate. Therefore, no sound can be made in a vacuum. This fact helps to explain the effect shown in the photograph. This photograph here, it's talking about how the alarm is inside a jar. This jar, the air, it was removed from this jar. So no sound waves will be detected. Okay. Now let's move to page 40. Page 40 and 41, they are talking about how we can hear the sound, yani how we can detect the sound. Here very important to highlight this part. The ear act like a funnel for sound wave. The ear directs sound vibration from the environment into the inner ear, where the vibration are converted to electrical signal. The electrical signal are sent to the brain, which is the same as sound. You can detect it as sound. Okay, now move to page 41. If you study page 41, this figure is enough to understand how you can hear the sound. These parts A, B, C, the direction of the sound waves will help you. You have to memorize these, very important. These are very important. Okay, now let's for page 40 you don't have to read this part because the figure explains everything on page 41. Okay, now move to page 42. On page 42 it's talking about what determine pitch. Here you have to know first the meaning of pitch. Here, highlight this part, sorry, is how high or low you think sound is. The pitch you hear depends on the ear's sensitivity to pitches over a wide range. Okay, this figure here very important. If you understand this figure, you will understand how frequency and wavelength will determine the pitch of sound. Here, as you know, the frequency is expressed by which unit? By hertz. This part very important. Here also you have to know the meaning of what is on 1 hertz. It means what is 1 complete wavelength. We took this, or cycle per second in a given medium. The higher frequency of wave, the shorter wavelength. So this part, if you understand the figure, you understand this part here. Okay. High frequency wave have shorter wavelength and produce high pitch sound. This part very important. A low frequency wave has longer wavelength and makes low pitch sound. We take here this one. These figures very important. If you understand this one, you will understand what is written here. So here also you have how different animals they can hear different frequencies. So some animals they can hear what we can hear, and some animals they can hear what a lower frequency than we do. So this one here, this don't memorize exactly what is the frequency for each one. Just in general, you have to understand different animals they can hear different frequency. Okay, let's move now to page 43. On page 43, what makes sound loud? So first I want you to highlight the meaning of loudness is a measure of how well a sound can be heard. Okay, or heard, sorry. Here this part very important. Also here the measure of how much energy a sound wave carries is the wave's intensity or amplitude. Okay, and as you know, the amplitude of a sound wave is the maximum distance that a particle of wave medium vibrate from the rest position. You know this part. In this example, read it. Okay, one way to increase loudness by using what? Amplifier. This part is important. Okay, so and the amplifier increase what? The sound wave's energy by increasing the wave's amplitude, which make the sound what? Makes the sound louder. This part important. Study these highlighted lines. Let's move to page 44. On page 44 here, loudness, its character. How is loudness measured? Is characteristic of sound that can be calculated by intensity of sound wave. This is the loudness. Okay, Loudness is characteristic of sound that can be calculated from the intensity of sound wave. This part is important. Unit decibel is important to know this unit, the most common unit used to express loudness. This one is to express what? Loudness, okay? Here also you have to know the meaning of a decibel. So 1 decibel is what? 1/10 of a pill. This one is enough to understand this one. Here for bell, the base unit, although the bell is rarely used, so it's enough for you just to understand what is decibel. Is the unit to express loudness. The softest sound of most human can hear are at level what? 0 decibel. And sound that are 120 decibel or higher can be what? Can be painful. Also on the next part, here, how loud is too loud? What I want you to study here, this part here, very important. A loud sound can damage the hairs on the nerve cells in the cochlea. Once these hairs are damaged, they don't grow back. This part very important. There are simple ways to protect your hearing, so you have to know the ways. We use earplug, block loud sound, lower the volume when using earpods, and move away from the speaker that is playing loud music, okay? If you double the distance between yourself and a loud sound, you can reduce the sound intensity by much as 1/4 of what it was, okay? This one very important. The highlighted lines are important. Also here, I want to talk about page 45. It's talking about the Doppler effect. For Doppler effect, I want you to understand the meaning of Doppler effect. This one here is a change in the observed frequency of wave when the sound source, the observer, or both are moving. Okay, this meaning. And this one here, this paragraph down, it gives you example when you and the source of the sound are moving closer together. The sound wave are closer together. The sound has higher frequency and higher pitch for sure. When you and the source are moving away, so it will be a lower pitch. This part here, the underlines, this one is very important. All of it, okay? So all of it is important. Don't forget to study this page here. This page, quiz yourself. Page 46. Study these questions. You have the answers. Also on page 47. You can study. You have to study it. You have the answers. I already posted the answers on portal. I want you also now. Let's move to the second lesson. The next lesson, it's talking about interaction of sound waves. This lesson here is started by questions on page 49. Also here you have true or false questions. Humans can hear sound at any frequency, so this one true or false. Try to remember the previous lesson. Actually no, this one is false. Okay, so this one is false. Sound wave can combine to become bigger or smaller. Think about it and what we studied for this lesson. So sorry, this one is true. It is possible to break a crystal a glass by singing a certain note? Do you think this one is possible? Think about it. So this one is also true. It is possible to travel faster than the speed of sound. Do you think so? This one is also true. Okay. Let's go now to this lesson here. What affects the speed of sound? What are the effects that affect the speed of sound? We have two factors. These two factors, the first one is the medium. Okay. And as you know, the medium, here, let's start talking about how it will affect. Sound travel fastest through what? Through solid, because solid are denser than liquid or gases. That means that the particles are packed closer together in solid. A sound wave makes the particles of matter move as it travels along, so the wave is fastest when particles are close together. This part, very important. Okay. The second factor that affects the speed of sound, which is the temperature. Okay, so what I want you here to know or to highlight this part. The higher the temperature, the faster gas particles move about. Particles of material move more quickly and transfer energy faster at higher temperature than lower temperature. Therefore, sound travels faster through what? Hot air than cold air. And don't forget to study this one. It was homework for you, how to find the distance, the speed of sound in steel at 20 Celsius is 5,200 meters per second. How far can sound travel in 5 seconds through steel at the same temperature? This one, how to find the distance by multiplying the speed times time. Okay, so you will get the answer. I'll write it here by using different color. The answer is 26,000 meter. Unit is meter because I'm talking about what? I'm talking about how far. It means I need to find the distance. Okay, now let's move to the other part, which is on page 52. How do sound and matter interact together? Actually, sound, it might be it might be reflected or absorbed. It depends on the material, okay, or the barrier. Let's talk about matter can reflect sound wave. It's like all wave can be reflected of matter. Reflection is what is the bouncing back of a wave when the wave hits the barrier. You know the meaning of reflection. Okay, so the strength of reflected sound wave depends on reflecting surface. So sound, this part very important. Waves reflect best off smooth what? Hard surface. A sound and a bar. This one here is example. Okay, just read it. The second one, matter can be what? Absorbed. Also depends on the material. So here, when a sound, sometimes matter absorb. Some matters they can absorb sound wave much better than other. So a rough wall will absorb sound better than a smooth wall will, and soft material absorb sound better than hard materials do. And this one here is explaining an example. Okay. Now on page 53, it's called it's talking about echo. I want you to know the meaning of the echo. this part here is important, is a reflected sound wave. So reflected, very important to know this part. Matter that absorbs sound wave will reduce echoes, okay? But the reflected sound is what it's called. It's called echo. So the strength of a reflecting sound wave depends on what? On the reflecting surface. This part very important. Echo can be reduced by this part very important. The presence of soft material and rough irregular surface. Rough surfaces reduce echo by scattering sound wave. Here we talked about some animals. They use echo for what? To find they find their food or okay. So here some animals like dolphins. You have to understand these examples and study them. Okay. The use of reflected sound wave to find objects, it's called what? Echolocation. This part is important. Here also one example of echolocation technology used by people is sonar, sound, navigation and ranging. This example is important. Sonar is type of electronic echolocation that uses echoes to locate objects underwater. These are very important. They highlighted points. Also, let's move now to page 54. On page 54, it's talking about interference. The meaning of interference is important. Highlight this part. Happens when what? When two or more waves overlap and combine to form one wave. Okay, read this part here. This part here, just reading. Okay. Here let's talk about the what اللي هو interfering through اللي هو constructive interference and destructive interference. Let's talk about these two and the meaning of them. The underlines here very important to know the meaning of constructive interference, occur wave overlap and combine. This one, all of it is important. Can cause what? Loud sound. This one, it causes what? Loud sound, such as what? Sonic booms. The destructive, the meaning, waves combine to form a wave with a smaller amplitude. Okay, this part here to the end is important, the underlines. Okay, this one is an example. Just read it. Just read. There was some noise cancelling headphones use destructive interference. This just for reading. Okay. This one here, very important. How does interference cause sonic booms? This part very important. Read it. It's very important. I want you to study the highlighted lines. Just hold on. So this one here, study it, read it very well and understand it. Okay, this part, understand all of this part about the sonic booms. Read it and understand it. Okay, let's move now to page 56. It's talking about resonance. In resonance, I want to remind you about the meaning of resonance happens when sound wave matches the natural frequency of an object and causes the object to vibrate. So this one here, highlight this part, the underline here. Okay. Also, where can a resonance occur? This paragraph is very important. All objects have frequency or set of frequency at which they vibrate. They are called natural frequencies. are resonant frequencies. Resonant will happen wherever an object vibrating at or near the natural frequency. This part very important. Okay. The frequency of a second object causes the second object to vibrate. So this is where is occur. Okay, will happen wherever an object vibrating at or near the natural frequency of a second object cause the second object to vibrate. This part very important. Don't forget to study the figures. Figures are very important. This one, a vibrating tuning fork can cause what another object to start vibrating if the fork and the object share the same resonant frequency. This one is an example, the tuning fork also. This one here is important. So this one for this part is enough to study for this lesson. The last page to study is page 56. Don't forget to study the next, not this one, this page here, page 58. Quiz yourself, it has questions. Also don't forget to study these questions. I already posted the answers on portal. And if you have any question, you can send me your questions. Thank you for listening.